another way of analyzing the pipeline execution of the instructions, as we talked about that, say division of instruction into 5 stages means a 5 stage pipeline, which in turn means that up to 5 instructions will be in execution during any single clock cycle. So we must separate the data path into 5 pieces, with each piece named corresponding to a stage of the instruction execution, like in this one. So this is the instruction execution, instruction fetch phase. This one is the instruction decode or register file read phase, where the instruction is decoded here, and then the registers are read. And then the execution phase, where the instruction is executed or the address is calculated depending on what instruction we are executing. Similarly, this is the memory phase and the write back phase, which write the results back into the memory. So you might be wondering that where does this mux come from? This is the same mux which used to be here, so we have just dragged and put it here. It does not make any difference. Okay, so generally what happens is the instruction flow from left to right. There are two exceptions, however. So when I say the instructions flow from left to right, means like it follows this path first, and then it proceeds ahead into this stage, and then this one and this one and this one, so on. Okay, but there are two exceptions here to the left to right flow of instruction. First of all, the write back stage, and the second one is this path. So any R type instruction, any immediate type instruction like add I or I and I, all of these instructions write the data back into the register. So that is why the data flows from right to left. Similarly in this path, so this is the path followed by the BEQ, which actually updates the PC depending on when the branch condition is satisfied or not. Okay, so this path causes the data hazard, and this one causes the control hazard. Why it causes the data hazard? Because the instruction that is being executed in this phase, it will be writing the register back into this register file. But where will it be writing to? Which register will it be writing to? So for example, if this instruction, let's say add instruction here, it will be writing to, some register, the data into some register, but the instruction in this phase will be specifying some RD value. So it might end up writing this instruction in the write back phase, might end up writing to a wrong register. So that is one of the reasons it causes data hazard. And the control hazard, that by the time we reach to this point, the next instruction might have already been fetched. It could be a next instruction in order, or it could be a branch instruction. Okay, so that also causes a control hazard.